Welcome back, chemistry fans. Today, we are going to talk about Unit 6, and this is topic 1 of a really challenging unit talking about stoichiometry. So if you have yet to dive into what stoichiometry is, it's just a fancy word for dimensional analysis. If you're saying, what the heck is dimensional analysis? It's the process of converting one unit into another, but we're going to do it with respect to a balanced chemical reaction. So let's jump into what we need to talk about today as far as these practice problems are concerned. Now, I'm going to do these in 2 different ways so that you find the method that works best for you. I think that you will find it is the ratio method, but let's make sure that that's the case. So this reaction is balanced in number 1 and number 2. It's saying in number 1 that you're given 32.1 moles of the C6H10. So what I'm going to do is I'm going to establish this as my starting unit. So I'll write down my moles and I'll write down what the material is. Then I'll write these train tracks going across here, ladder, scaffolding, however you want to say this. What we're trying to convert to is the number of moles of CO2. Well, to convert from moles of C6H10, we have to take how many are in the balanced reaction. So there are 2 moles of C6H10 for every 12 moles of CO2. So they're in a 1:6 ratio. Well, once I then do the cancellation of the similar units, I end up with the unit that I desire, and this becomes my answer. So 32.1 divided by 2 times 12 gives me 192.6 moles of CO2. Now, let me show you how you could do this in a maybe simpler fashion. It might make sense to you. What I would suggest doing is taking the balanced reaction and setting up ratios. Put an X over the one that we desire, put a 32.1 over the unit that we are given. Now, because this is in moles, we don't need any kind of conversion. So it would just end up being 32.1 over 2 equals X over 12. And then it's a cross multiplication. So we would just cross multiply. You could actually leave the 2 where it is, or you can cross multiply that as well, and then divide both sides by 2. So we would have 12 times 32.1 equals 2X. You would need to divide both sides by 2. And you end up with the exact same answer. Okay. So that is question number 1. Now let's jump down to question number 2. It has the exact same balanced reaction. So what I'm going to do is I'm going to flash back up and down to that balanced reaction. So I've got 125 grams of O2, and we want to find the number of grams of H2O. So let's go and see this balanced reaction. What's the ratio between the numbers that aren't crossed out? So it's a 17:10. So what I got to do is eventually I'm going to put that 17 in here. So it's a 17:10 ratio. I'm just writing this down for memory's sake. Now, because this unit is grams, the unit that I must start down here with is the weight of O2. So it's 32 grams of oxygen for every 1 mole of oxygen. Now, I can make the conversion from moles to moles of oxygen to moles of what am I looking for? Water. So I've got 17 moles of oxygen for every 10 moles of water. Now, where did I get those from? Again, that's coming from the balanced reaction. If we're looking at the balanced reaction, there are 17 of the oxygens for every 10 of the waters. All right. So now to get this mole unit that I've got converted into grams, I'm going to have to say for every 1 mole of H2O, there are 18 grams of H2O. Now, where am I getting these weights? I look on the periodic table. Sorry, let me go and find that periodic table. Periodic table, the weight of oxygen is 16, so O2 would be the 32. The weight of hydrogen is 1. So if I have H2O, that would be 2 plus 16. That's where I get the 18 from. All right, so let's now go back here now that we've investigated where those values are coming from, and let's simplify to get an answer here, multiplying across the top 125 times 10 times 18 divided by 32 divided by 17, and I get 41.4 grams of H2O. So that's my answer. Okay, now normally, yes, we'd be done, but I'm going to show you the path that you can take using a ratio method. So I'm going to erase all the stuff that we've done up here already, get rid of it. And where I'm at now is I am given 125 grams of the O2. I'm looking for grams of water. Now, in the previous example, we crossed out the O2 or the C6H10 and the CO2. Well, this time, though, we're going to substitute in the weights off the periodic table. So we're not going to use those letters because you can't do anything mathematically with those letters, but we're going to substitute in the weights for those compounds. Now we've got a cross multiplication. I've got 125 over 17 times 32 equals X over 10 times 18. You cross multiply. I would have 125 times 10 times 18 equals 17 times 32. 1732X. Divide each side by 17 and 32. And magically, everything is going to work out to be the exact same answer. So it's just two different paths to the exact same answer. You use the one that makes more sense to you. Do you want to talk about cancellation of units, or do you want to work with the idea of a ratio? How does it make sense best to you? It's up to you. Use it and be productive with it. Thank you so much for your day. Hopefully the homework went well. Bye-bye.